All right, problem 3-63 says given that n is the length of the bottom edge of the backward L-shaped figures below, what sequence is generated by the total number of dots in each figure? What is the 46th term, or t of 46, of this sequence? And what is the nth term? So there's several ways you can do this problem. I'm going to look at it straight like it is a sequence. And when I deal with sequences, I like to look at my different terms. So my first term here, okay, is going to be 1. And what I'll do here is I'll make a little table here so I can kind of keep track of all of this information. So remember, n is going to be my term number, and t of n is going to be my actual term. So remember, our first term in our sequence, it would be like where our n equals 1, but I'm going to go ahead and throw a 0th term in there because I know I'm going to be trying to find the rule here. But I have 0, I have my first term, second term, third term, fourth term, and fifth term. And we'll look at making a table here to see if that will help us to kind of figure out what kind of sequence we're dealing with. So my first term there, or n here, is 1, and our total number of dots here is also 1. So the first term in this sequence would be 1. The second term in the sequence here, well, how many dots do we have? We count them up and we've got 3. The third term, we look at it here, we've got 3 here, and then we're adding an additional 2 more on the top. So we are looking at a total of 5. Fourth term in the sequence, well, we've got our 4 here, and now we're adding 3 more. So we have a total of 7. And you can look at it in different ways there. This one, notice here we have 5 here along the bottom there. And then each time it seems like we're kind of adding one less than our term number here to our side. So we have 5 along the bottom, and then we have 4 that have been added on top of the last one here. So each time here, when we add those here, we're ending up with a couple more. So in that case, we have 9. So because we've studied sequences here, we can look at this and we can say, well, is there a pattern to it here? And I'm sure you probably see it there that each time we go through here, we add 2 additional ones there. So since we're adding 2, or our generator is going to equal, or it's that we're adding 2, we have, it's safe to say here that this is going to be an arithmetic sequence. So remember, the other part that we need in order to come up with a rule here would be what our 0th term would be. And if we think about our first term was 1, and if we go backwards, that means we'd have to subtract 2. We'd end up at -1 here, because 1 minus 2 give us -1. So our 0th term, we're looking at, it would be a -1. So using what we know about arithmetic sequences, we can take this and we can look at it and say, -1, to get to our first term here, we had to add 2 one time. To get from -1 to +3, we had to add 2, and then we had to add 2 again, so we've added 2 times. To get to our third term, we had to start here with -1, we had to add 2, and then we would add 2 again, so we've added 2 3 times. So when we're trying to come up with our general rule here, I could say that t of n, okay, so we're looking at it, we keep starting at -1, so our 0th term was -1, and each time we're adding 2, and since we're adding 2 repeatedly there, the way that we show that we're adding 2 again and again is by saying we're multiplying it n number of times, or multiplying 2 times n there. So we've added 2, we've added 2, we've added 2. So it's a total of adding 2 n amount of times. Now, how is this going to help us with the rest of this here? Well, when we look at what is the 46th term in the sequence here, or t of 46, we can take that and we can plug it in here and say t of 46 should equal negative 1 plus 2 times 46. And now we simply take this side here and just simplify it down. So use your order of operations. 2 times 46 should give us 92. So we have negative 1 plus 92. And when we add negative 1 and 92, we should get 91. So our 46th term in this sequence should be 91. Now, we've already kind of answered what the nth term in the sequence would be. If we look at it here, go ahead and box this in here so we recognize that is the answer for our one part here. The 46th term was 91. If we're looking for the nth term, well, this is our nth term. So we're always going to take whatever our term number is, we're going to multiply it by 2 and add a negative 1. So this explicit equation that we've come up with is actually going to help us to see that the nth term here, whatever we're trying to find the nth term, is negative 1 plus 2 times whatever that term number is. So this is our nth term. This is not the only way to recognize this sequence. There are other ways to do it there. If you see another way to do it and you come up with the same answer and information, that is fine. That is fine there. So if you have questions, please make sure you ask your teacher. I hope this helped you out with this problem here. This is problem 3-63.